So I created this tutorial for those of you who are brand new to Grasshopper or fairly new and want to learn it for fabrication, architecture, 3D printing, or whatever. This exercise will share with you how to create this box. It's a parametric box. You can change all of these dimensions in terms of the wall depth, wall height, bottom height. So this ties it all together and creates this parametric box, even with some tolerances. So if you're new, if you want to see how this works, you can download this from my website and follow along. If you have any questions or anything, let me know in the comments below. I want to make sure that I answer all of the questions. And if you have ideas for future videos, also let me know in the comments below. Thank you very much for being here, and let's jump into the tutorial. First thing we're going to do for this tutorial is bring in a rectangle, and also keep in mind that we are using units of millimeters, which is fine. You can actually use any units, and all you have to do, let's say if you're going to use them in inches, then you just change the sliders to match whatever units you have. So now that we have this, let's start by creating the base rectangle. So let's go here, double click and free space, and bring in a rectangle component. What this does is it creates a rectangle on a specific plane location, and then you can change the X and Y size. So let's change that. We'll go 100 in the X, 100 in the Y. Now let's go 50 here. And the reason why we want to do that is because if you are going to create a rectangle and not a square, then you actually have to take a few different steps. So I'm going to show you how to do it with a rectangle. That way you can make it also for a square if you'd like to do that. So now with this is our base geometry, which is going to be the outside face of the box. Now what we need to do is offset in the same way that we offset inside of Rhino, but here we'll just bring in a component to offset this rectangle. I'll plug in this rectangle into the curve input, then bring in a negative component. Why? Because it's offsetting here. I can tell when I select the component, it's offsetting to the outside. So to offset it to the inside, we can, we'll say 2.5. And whatever number you pick, it's going to create a slider with a limit of 0 to 10. And if it's higher than 10, then it'll go from 0 to 100. Now let's plug in this distance in. Notice that we could now pick however deep the wall of that box is going to be. So what we'll do now is, now that we have these two, we're going to create a surface in between those two. Now to do that, we'll use boundary surfaces. And this, what it does is it creates a surface when you have a collection of closed polylines or closed edges. So if we plug this in, it'll create it for the outside one. If we hold down Shift and add this one, it creates one for both the outside and inside. But if I flatten the input, it'll look at it as if both of those were together, not reverse, but flatten. And now we have a surface in between those two offsets. And this is very useful because now we have this parameter that we can use for the wall size. So let's say if it's going to be 3 millimeters for the wall, then we can pick that size. And we can relabel these, but sometimes I tend to copy these. So if I label it and I copy it, then I have to change the name again. So I sometimes leave the labeling towards the end. Sometimes that does get a little bit confusing. So if your script is too long, then I would probably take a different approach. So now that we have this surface, we're going to extrude it up in the Z direction. So let's bring in two components, extrude, and then unit Z, because when you extrude something, you actually have to tell it in which direction. So now plug in the surfaces into the base, and then the Z vector is going to go into the direction. And by default, this has a number 1 in it. Now, obviously we want to be able to change how tall the box is going to be. So now we'll bring in a new slider and we'll say 25.5. And this allows us now to extrude this box as a solid in between these two offsets where we created that surface. So hopefully you're starting to see how the logic works here. If you're fairly new, it goes from left to right, where the inputs are on the left and the outputs are on the right. You cannot go from input to output, and you cannot go from this one into an input. So that's kind of the logic of how this works here. And now we're going to move on and create the bottom part of this box, and then continue on with some details that are pretty practical when you start with parametric design. So if you have any questions, you'll be able to download this on my website. All right, so what we'll do now is, now that we have this extrusion, well, now we need to create the bottom of the box. Now, there are different ways we can do that. Let me annotate here. Give me 1 second. I want to show you that if, let's say, there are different ways that we can create the box. We can extrude the bottom. We can also extrude to the inside. So create a box on the inside. And that's the approach we're going to take. The reason why is because if we extrude the surface down, then we actually no longer have the true dimensions that we have here. So if the height was 50, well, it would be 50 plus the bottom portion. So what we're going to do is take the offset curve that we offset for the wall, and we're going to create a surface there using boundary surfaces, so we can reuse this component to create other portions of the script. And now with this surface, we're going to extrude it up, and if we want to use the same wall size, then we could do that. But what we'll do now is take this and extrude it. So I'll copy this down because we're extruding in the Z direction. Now it's extruding by the same amount as the height. So now what we need to do is, if we extrude it by the same amount as the offset, we now have the bottom, the walls, and they change at the same time. So if the walls are 7, well, the bottom one's 7. We can also change that for it to be independent. So if the walls are 5, let's change this here to 5. We can also make the bottom to be half, so we can also do a mathematical division, or we can just plug in our own and say 2 for the bottom part and 3 for the walls, or 5 for the walls. Now, the next thing that I want to go over is whether you want this to be 2 separate objects or you want them to be together. Sometimes you want your box to be a solid. Sometimes you want to fabricate it, so you want them to be independent. One of the things you can do if you do want it to be a solid is you can type in union and bring in a solid union component where we plug both of these in, flatten the input, and ultimately have one box. So middle click and bake it so you can see it. That is a solid, but it has the bottom already grouped into it or merged into it. So what we need to do is select this and type in merge all coplanar faces, and you'll see that we actually remove the crease. And so that's what we would do within the script. Just take this and type in merge all faces. Now you don't have that crease, and you can still change all of these parameters. So the bottom could be 6, and the walls could be 3, and so on. So all of these parameters can be changed. All right, so we've got this box that we can change the size. We can change the wall depth, and we can change the height and bottom plate. So the next part is to create a lid for this that fits it and also has a little bit of a tolerance. So this is more of a basic tutorial, but this goes over a lot of things that are critical once you get into creating more complex scripts. So let's get into creating the lid for this. So what we'll do is go back to the original polyline or the original rectangle, and we're going to move it up to the top. Now notice that we already have the height, so we can just use that number to move this rectangle up. So what we need to bring in is a move component, bring in a rectangle component into the geometry, and now we can just plug in the height or the z vector into the motion because we're moving it up by the same amount in the same direction. Now that we have this, we can start creating the lid. So depending on where you want to organize your script, you do this up here, you can do this down here. Since the lid is on the top, it kind of makes sense to bring it up here. All right, now let's offset this curve. And we'll do this by a specific amount. So if it's, we'll just do 0.500 for now, and this will be the tolerance. Now we're technically going to do the same thing that we did for the wall or for the box, but we're going to do that for the lid. So offset curve, and this is good because this gives you a little bit more practice doing similar things. So offset it. What number should we use? Well, let's use the same number as the offset from before. So I'll bring it over, tap Alt, and it creates a copy. Now I can use this number as the distance, and it doesn't have to be negative because this time it's okay if it's to the outside. Let's just go here to 5. All right. Now let's take these two and create a surface in between them. Remember that what we use for that is boundary surfaces, and we plug both of them into the edges, holding down Shift, and then flatten the input. And now we have a tolerance gap. We can also make it 0. And then the distance for the cap, for the lid. So let's go here to 3. Now we're going to extrude this down, and that's going to be the depth of the lid. So extrude. In which direction? Down. So z vector, so up and down, but down means in the negative direction. Now let's use a number. We could copy this slider. So slide it over, tap Alt, and you can make a quick copy. All right, next. Now that we've created this lid, which has a tolerance gap, it has offset for the walls. Now let's take the offset curve, which is the one all the way to the outside, and create a surface there. So boundary surfaces. And now we can extrude this up to create the height for the lid. So let's extrude. In the Z direction, up, not with the negative. So I'll slide this down, tap Alt to create a copy, or you can do Control C, Control V. And now this will go into the direction. Now, obviously 10 is too much, so let's go back to 2. And if you want the lid and the cap to be the exact same depth, well, we can plug both of those numbers into 1. Let's go here to 2. Actually, that makes it a little bit easier. But if we do want some variability, we do want to have this. And the reason why I do this is going to become a script that I share. So I want to have the ability to change those individually. All right, so we're going to be doing the same thing that we did here. We're going to put together these two forms and merge the coplanar faces so we get rid of the crease. But let's do one at a time so you can see the process. So let's go here to, I type in union, and we're going to bring a solid union between the lid and the top part of the lid. I like to hover over the output, and if it says 2 values, that means that it hasn't been put together into one. So I tend to flatten the input, and that usually fixes it. Now it doesn't fix it every time, but in this case, when you have coplanar faces and pretty straightforward geometries, then you won't have too many issues. Now, notice that these are overlapping, so I'll disable preview. And notice that we still have those creases here. So let's merge all coplanar faces and disable the preview on all of the stuff that we did before. Notice that now this is a perfect box that has a tolerance gap for the lid. It has the size for the offset for the lid, the height for the lid, and the lid is dependent on the original size. So if this is 50, then it's going to change and the lid is going to change. So we're not necessarily changing the size of the lid anywhere except for on the original rectangle. So now with this, let's see if we got everything working here. So first thing, this is going to be, let's relabel these X size, Y size, box wall depth, and sometimes I like to group it and give it a little bit of a different color so I know that those are the sliders that I can change. Now this is going to be the height. And this is going to be the bottom height. Now I can disable preview on this because it looks like it's overlapping. Most of this stuff can be disabled to preview because the only last things that we want to see are the results of the clean box, and same with this, the clean lid. So let's continue. We got tolerance gap. So let's go 0.5. Lid tolerance. Then here we have lid wall depth. And on this one, lid height. This is going to be the lid top height. Now, here's the thing. We have everything organized. The only last thing I like to do, and this is not necessary, you can just use this as the output and this as the output, but I do like to see the final outputs all the way to the right, and then copy this and do the same thing with this one, and then group it. And then now we can disable the preview on all of that, and then label this lid, and this one's going to be box. All right, so at this stage, now you know how to create this box. Now, if I went a little bit too quick or you don't know how this came together, you can always go to the website, download the script, and see how it was made. You can download it for free temporarily, but if you have any questions, let me know in the comments below. Hopefully you found this interesting. So if you're into fabrication or into architecture, a lot of these steps can be used for other designs. So thank you very much for being here, and I hope to see you on the next video. Actually, here at the end, I want to do something that I don't typically do with these beginner tutorials, is I'm going to take this whole script and I'm going to turn it into a cluster. So not only will you know how to create these scripts, but then at the end, you'll know how to simplify them into inputs and outputs so you can use it over and over again, or even share with your colleagues or whoever you want to share it with. So let me show you that part of the process. It'll be a bit of a time lapse, but I think it's critical for you guys to see that part as well.